luckily it has the same property as the base 10, whereby if you say like $10 is the same as like $0, $10. But the difference is when you now have the decimal point. When you have a decimal point, things are definitely gonna change. But if it's like, you know, an integer like a whole number, the zero in front of it is always, it doesn't matter.
But all you can add is ones and zeros
For
that, like, the problem is like 1 plus 1, but so it'd only be like 1 plus 0 or 1 plus 1, you couldn't really do anything else besides ones and zeros, right?
You know, the answer to this question is going to make you understand more. Okay, so now you said the only questions that you can, the only numbers that you can add is just 1 and 0, right? Because binary is what?
2.
That's power of 2. But actually, what are the numbers for binary? They're all zeros and ones.
Right.
Right? You cannot have a 3 there. You cannot have a 4. It's just zeros and 1.
So like when it comes to doing these addition problems, how many ones and zeros can we stack? Like
that's a very good question.
On a question, could it be like 1 plus 1 plus 1 plus 1?
Yes.
Yeah, because if you
Yes.
like 1 plus 1 plus 1, would that be the binary to 3?
Yes.
Gotcha.
But we will come to that. So I understand your question. You're saying if we have 1 plus 1, 1 plus 1 plus 1, right? This is actually very easy. So this would be 3. But instead of 3, you're going to have like,
Gotcha.
I'm glad you asked that question. But what if we have 1, 0 plus 0, 1 plus 1, 1? Let's not go here for now. let's keep it easy for now.
Isn't that just
Would that just be A? Because it'd be the 10, 10.
Oh, I wiped it up. Let me see.
Like
1,
2
0,
plus
0, 1
It'd be
plus
this-
1, 1.
2 plus 1 plus 3, right?
I figured that would be
Yeah.
22, which is, in other words, 10, 10. So it could also just be A if you look at that board.
2 plus 1
So-
plus 3.
So for this is going to be a little bit tricky because 1, 0, definitely it has to be specified that this is just 2 bits addition. So when we have 1, 0, which is 2, 0, 1, which is what? 1, and 1, 1, which is what? 3. For me, an easier way would be for us to transform each bit. 2 plus 1 plus 3, that's 6. And then, but the 6 would now be over the 2 bits. It's going to need up to what? 3 bits. Because the 6 actually is 0, 1, 1, 0. But the 0 doesn't really matter, so we can just have 1, 1, 0. Another way to do this is to add it actually. So 1 plus 1 is 2, right? So 2 is what? 1, 0. So we add, so 2 is what? 1, 0. This is a little bit higher. Don't get confused. If you do, that's still okay. So 1 plus 1 is 2, okay? And 2 is what? 1, 0. But we cannot really write 1, 0 right now because we still have some things to add here. So we have to write 0 and carry this 1 over here. And then we have what?
1 plus 1 plus 1.
We have 1 plus 1 plus 1, which is what?
3.
3. And 3 is what?
1 more. Gotcha.
ask this question? Great one. I've not done this in years actually. So when you ask that question, I'm like, let's try, and I'm glad we got it. So the good thing is that you can actually add in binary, you can actually add in base 10 and then just convert it. And the good thing is that once you do both and they're both the same answer, that's like a sure way to know that you got the right answer. Okay, exercise time. You all